Let's welcome everybody. I wasn't expecting more than 5 people at this point of the conference. Thank you for being here still. Question, who of you has, like, either this week or earlier read anything about the Trustable Software Framework method? Edmund, you don't count. Okay, most of you, who has no clue what that is? You are okay, like raise your hands because then I know kind of where I need to start. Okay, 1 or 2 people, okay. If you're missing anything, like if there's a gap or a step that I should be talking about, you will shout, please. We can also send the presentation to someone that has a working thing. All right. So intro. You can see a picture in a couple of minutes. I have been seeing, like, talking about with the guys that TSF method when it came up 1.5 years ago, plus or minus. I'm a software guy, meaning I'm coming from a world of like real computers, like always Linux plus, not embedded, which means complex applications, complex dependency chains. So that entire embedded world is something that when I started in the industry was new to me. And since then, essentially until today, I've been having conversations with safety people coming from that embedded space, talking about things like ISO 26262. And I've since then been trying to kind of overlap those two worlds because methodically speaking, there is not a lot of overlap between what these methods want you to do and a complex application that pulls into 120 Rust crates or something like that. But it simply does not compute. So based on that context, first time I heard about TSF, I paid attention because that was the first method that I saw that was trying to address this gap, to be formalized and formatted in a way that could actually be applied to a context like a complex real software project with complex supply chains and even open source development models. I looked into the method a bit. I talked with the TSF guys a little bit. Essentially, where I'm coming from, never having been part of an operational project that really does safety engineering, that's just not my professional expertise so far. I can understand the goals of all of that. I can understand the method, but how to really actually apply that, like how to get going, what is target granularity of your statements, etc., how to really actually put it into a real GitHub repo and so on, how to automate this, I had no clue. And the reason I built a little project that I'm going to show you today soon, this is like doctors trying to save the patient. I can send you an email with the presentation if that helps. Because I've got network, right, so that works. Sava, should I send it to you? Should I send it to you or not to you? Let's see. I thank you for bearing with us for a minute. We shall be. It's picky.
We almost made it to the end of the conference without any hiccup. So thank you, Daniel. Thank you, Daniel, for providing us some relief.
All right. So essentially, I decided to build a little Hello World style template example project where I can try all of that. Apply the method in a very, very shallow way, but apply the method, integrate it with the CI, automate as much as possible, and essentially create something that could become or is supposed to be an extended part of the TSF method documentation onboarding kit, if you want. And that's what I've built, and that's what I wanted to talk about today. Is that the right one? Let me attach the file. Some excitement at the end.
Yes.
So maybe while we wait, since that sounded a quite informed audience, so you've heard about the Trustable Software Framework. Has anyone tried to use it actually? Okay, that is. Well, I kind of thought as much, but. Okay, has any one of you been sitting in the workshop that we had? Yeah, okay, I see a couple of people.
All right. I'm trying to remember my slides. Okay, so I talked about what I was building here, and I will soon show you what I've built before that. The way I've been thinking about this, let's say, workflow or the application of a method like this. And before I go there, I'll have a quick 5 minutes or something about TSF, the method actually. Anyone who knows better, shout. Anyone who doesn't get anything, shout as well. TSF is a method that's supposed to enable you as a project to define and measure quality goals. Very generic. The method is essentially supposed to be generic, but also informed by the context of quality goals that are related to safety engineering. You know, things like reusability and, has to define what exactly your software is supposed to do, how do you measure what it's doing, etc., etc. But the method as such is quite generic, so it can be used to measure any kind of quality goals. I'll get to a couple of examples. And the way it works is, formally speaking, at the end of the day, it's the statements that you make, the goals that you want to reach, and how you break them down to simpler statements that you actually can prove. That's all done in little text files, markdown snippets, which live in your GitHub repo. So this is part of the code. There's no separation from what you're doing compared to what your goal description is. Part 1. It uses a standard open source graphing framework library .graph to kind of link these statements up into a tree, which essentially means you have a goal, and that goal is broken down into sub-goals, and if necessary, detailed out into sub-goals to a level of granularity where you're making a statement, a goal statement that you can ideally prove to be true or false. I'll have an example essentially saying a project should have documentation. An Eclipse project should have a good project README. My project has a good project README. Yes, no, I can prove that. Whether it's good, okay, that's a second stage beyond that, but you know what I mean. And essentially, first part of TSF, the method is having that conceptual framework for defining that tree graph containing your goals, and the idea to, as you work through what you're doing, you're detailing out the graph, you're adding statements wherever you want to kind of increase the coverage of your quality goal and measurement. That's the idea. That's the first part. The second part of the method or of the project is a little tool, also built by the TSF folk, which essentially is used to manipulate that graph, add an item, link an item to that parent, remove an item, etc. Also, that tool is used to compute the score, the quality score based on the evidence that you're providing for items. So, I should have a README. Here's my README. Okay, you get a 1.0, and then you get that kind of computation across your graph. You sum up your subscores, and as you go up to the top, and you end up with a top-level score for that thing that you're doing. Essentially, this can be considered a metric that, for instance, you can use in a simple dashboard. I'm improving over here, but this got worse. Or I can use that metric to kind of reject or not reject a pull request, because it did improve or not improve that metric, like a code coverage test, for instance. That's the kind of operational thing you can do with that number. Hey, thank you, Sarah. No? Almost there. Let's try to catch up with what I've been talking about. What did you do? All right. Okay, let's recap. Context, why I told you the story, why I became interested in TSF. That is the slide for that. commercial versus open source development models. Open source projects are understaffed. People don't have time or patience for meta things that they don't see a value in. That's a bit, let's say there's different motivations and different resource situations in commercial projects because, having a heavyweight and a complex process over there, well, you charge your customer for it, right? That's fine. That's how we do safety in the industry for like a long time. Essentially, the gap that I was talking about. Then also what I spoke about, TSF, when I saw that thing, I thought I recognized that there's design goals here that help bridge that gap, that make that kind of method applicable to a project that needs to automate everything, where people do not have a lot of time and patience for meta things that they don't see a value in. So that's the recap for that. Now I started to speak about the TSF method. This is an example for the core TSF part of that graph, a little snippet, but essentially, what I said, there's high-level goals that are broken down subsequently into more specific goals, and you as a project applying the method, you will detail out that tree down to a level of granularity where you can actually make true for statements based on what you're doing. That's the idea. There's different areas, measurement areas proposed by the core method. You're free to extend them, but things like expectations, aka the bad word requirements. What is this supposed to do? How is it supposed to do that? How is that thing building? Can I reproduce the builds? All those kinds of things are part of this core framework. Quick, my last information regarding is that thing actually worth a damn? You guys can update me if I get this wrong. The latest statement in that context that I have that I'm aware of is the method as such has been essentially accepted or approved, quote unquote, by a validation authority to be sufficient, if applied correctly, sufficient to achieve quality assessment goals like ASIL for automotive. So the method as such, again, if you apply it correctly, etc., should get you there. That's my latest. All right. Okay, now that was the intro. Now we are synced up again. Any questions so far? No? Okay, keep them for later. All right, now applying the method to something tangible, to something that you are actually doing. That's what I wanted to figure out for myself, and also I wanted the result of that. Let's see what happens. But I was hoping that the result of this, me figuring this out, can actually be maybe useful to other projects in maybe this community. That's why I called the talk Scaling TSF. I'm not right now, I'm not thinking about scaling this to a huge project, but scaling this into a community. So that's the idea behind what I've built. And the conceptual approach, or like my mental model for how I was thinking about what I've been building, is that applying a method like this essentially breaks down into two phases or two things that you do, in my mind. Again, people who know better, please feel free to correct me later. The first intro stage, if you will, is selecting the method and doing an initial adoption, tailoring, contextualization of whatever the method is to your context. Right? So you select whatever you want to do, and then you set it up, and maybe you can do a few initial kind of tailorings of that graph to make it fit your context, and maybe kind of hide, disable certain parts of that branch because they don't apply, etc. That kind of customization. Stage one, that's what you do to get started. You do that once, ideally, or only occasionally, right? But that's set up. Stage two is the day-to-day, like as you're developing your thing, building your thing, you write code, you write documentation for the code, maybe tests, specifications, etc. That stays the same. The idea now, if you're applying a method like that, is you have to do two extra things. Extra thing number one, you will have to continue to expand and detail out your TSF goals graph, right? You're doing something new. That new thing ideally will support or aim for supporting a quality goal or some aspect of the graph. So you have to maybe create a new part of the graph, and you don't, that you then work towards. Like for instance, I now need a README for my project, so I can expand that part of the quality graph to make a statement. I have a README with those kinds of attributes, for example. That's part one of applying TSF on top of your regular workflow. Part two is you need to provide evidence that you actually are doing something for the goal you just defined. So if my goal is have a README, well then I should think about how, for instance, doing a release build that I do, how can I now formally, ideally prove, create a link between I have a README, this is the goal, you can score this now. Like, how do I document, link evidence to support my quality goals? So that's the day-to-day thing that you do while you build your project, while you build your thing. And based on these steps so far, the initial setup and the day-to-day, you now have a lot of information, a lot of structure that you can use for automated generation of dashboards, of reports, of the scoring of your project documentation, etc., etc. So like build pipelines, release, PR merge pipelines, etc. can now use all of that to do interesting and hopefully helpful things with that data. So that's the 3 stages. Stage number 1 is that contextualization tailoring of the method of your graph. I have not been doing a lot of that in my project. However, this is where I think TSF has a lot of applicability and value add for an open source community and development model, because I was talking about, here we go. I was talking about tailoring your project to a context. What is a context? Context can, for instance, be a technology context. Every Rust project, for instance, comes with a bunch of features, capabilities from the language definition, from the Rust compiler. There's a lot of Rust ecosystem tools that help reach quality goals. The cargo, the crates infrastructure is amazing, and again gives you a lot of tooling, a lot of input for free to reach some of those quality goals. So if you're a Rust project, for example, there is a lot of graph detail nodes that you can reach almost for free, but every Rust project can reach those quality goals almost for free because they all use the same tech stack. Not every Rust project, however, needs to reinvent and redefine the Rust-specific quality goals, right? We can share those. Once we have a Rust statement library with Rust quality goals, then the next project does not have to redo that work. We can evolve that together. And every project doing Rust can now pull into their quality graph the Rust-derived goals and can instantly, essentially, have a starting point for, getting a certain part of your tree scored. Second example is something like the Eclipse Foundation. The Eclipse Foundation defines the Eclipse project handbook and the Eclipse process. That's, formal development process-like definitions. For instance, they require that a project has a good README. We all share that context. So from those documents, you can derive 1 or 2 dozens of TSF statements, that formalize the Eclipse requirements into your TSF graph. And once we have that kind of TSF Eclipse context, we don't need to reinvent that every time. We can share it and evolve it together. Formalization of the Eclipse project handbook, essentially. So that's examples for what these tailorings might look like. And that is one of the huge things where I'm thinking the method being open and more than one project applying them in an open source style, we can share those contexts. I have created a Rust and an Eclipse library to get started. You will see, or you can see those in the project I've put together here later. Conversation is ongoing with the TSF folks because to make this work, right, that approach needs to move into the TSF project where we have a contrib folder and a little community process to manage that kind of library. But that's the takeaway for that stage 1. Where's the value add? Why is this cool in the context of an open source community? Stage 2, the doing the work part. I was talking about that. You need to define your graph and you need to link evidence of what you've been doing to support the statements, the definitions that you made in your graph. This isn't really something that can be automated because, that's where you have to have a brain, ideally a human brain, because something with intention and a real world model. But as I also said, TSF statements are little markdown files, ideally short and brief and simple ones. So, we can do that. what I've been doing in this project, you will see that later hands-on. I have built something to automate, only do once, the linking part between evidence and the supported statements. So that, if I create a README to support my quality goal for the README, I can now once in my CI in that case, document that connection for this node in the TSF quality graph. This, for example, file in my repo is the evidence, and I only do that one time and automatically going forward. In release builds, for instance, that link is used to score my graph, get the report, and so on. Again, you'll see examples later. At that stage 3, again, I'm not reinventing any wheels, I'm not doing any rocket science. I am combining all the tools that, for instance, the TFS guys use anyways, some other obvious things like mkdocs or GitHub pages for working with all the data we've now created. I've got the quality graph, I can do the scoring, I can create the report, I can embed this with my other nice project documentation in a good project website, and so on and so forth. Again, you'll see examples later, but this is essentially the automation part, the core of the automation part. All right, to get a grip, a little idea at least of what that actually looks like, we will now follow one example item through that process that I've built. And as I said, this is shallow, right? We are not talking about deep safety engineering. I'm talking about, do I have a README or not? Because it's supposed to illustrate the concept and not give you a 2000 graph node at this point. So essentially, but as I said, and as we just saw on that stage 1 slide earlier, you start by setting up your graph, meaning with the help of the TSF tool, you pull in the TSF core starting point graph. My idea, as I talked about earlier, for making this worthwhile in an open source context, you pull in an Eclipse-specific context library, which uses uses this generic statement to make a more specific one, like that supports the statement above. And this might not be all the breakdown that you do for that top-level graph, but it's certainly one possible breakdown. And then final stage, you do your project level things. The first part of your workflow, you add your own project specific mapping of this context. So I project have a README, like Eclipse told me to do, like TSF wants a project to do, right? That's what we're doing. Essentially, as I said, creating these little markdown snippets, there's tool support, you can just create a new file, put that sentence in, fine, whatever. Question or later? Okay. What I just showed you, there's a repo, it's public, you get the link later. Unsurprising, that's what it looks like, right? This is markdown, sentence, 3 different files, not rocket science, but that's what this looks like. One thing that is maybe worth pointing out is in the header of my project-specific one, there's something that you will not find right now in the core TSF documentation, this little placeholder thing here where it says evidence ref. So footnote, the TSF tooling essentially expects or is able to process evidence, any different kinds of evidence references in the header of such an item. So you can put a reference to a file or something in there, in a certain syntax that's defined by TSF. And that then, when you score your tree and create the report, that evidence will be looked at and inform the score. That's the place where this kind of evidence should go. Mental note for you guys for right now, I've put a placeholder here. There's a reason for that, we get to that. Reason for that, this is the second part of the workflow, of the day-to-day workflow that I was talking about, linking evidence to items. Again, I want this to be done only once, and I want this to then be automated, in release workflows and so on, so that I don't have to repeat myself. So what I've done To kind of do that, to enable that, is I've built a little GitHub action that I'm calling from my CI release workflow. GitHub action is creatively called TSF transfer, TSFer, and it doesn't do much. The only thing that it does, it records a relationship between a TSF node ID, that's the project README thing that you just saw, that's the ID of that node, and evidence reference information for that node. That's what that thing does. In my example here, the evidence that I'm linking is a download URL to my README file, which I have earlier uploaded to my release artifacts in that release workflow. So if you look at the GitHub page of that project at that release, you will see among the release artifacts my README file. The download URL for that file, for that release, I'm using as evidence for this node here. That's how I record the link. Again, please, let's not discuss that this might be a stupid example. That's not the point. The point is, however, and we can have breakout workshops, whatever discussions going forward, you can imagine that if you get a big tree in a big project, you will have to spend some time designing how you partition and structure your CI workflows, because obviously this will be getting big as well. That was it for the day-to-day workflow, essentially. You do that a lot if you're applying the method, but that's what you do. Once you've done that, this is now led towards the end of my release workflow. As I said, that's the automation where you use all the data that you put in. Again, what I'm doing in my example project is stupid and simple because the heavy lifting is done by other open source projects, the TSF tool, for instance, and others. What I'm doing here, I'm calling another GitHub action that I wrote called TSF link, and what that thing does, it collects all these evidence references that you saw on this page before, collects all of these from that entire workflow run context. It will then go through the TSF tree, and everywhere where this evidence ref thing is in the header, it will insert at that place, the relevant evidence for that item, so that my graph is now complete with all the available evidence. It will then run the TSF tool to score the graph, to create the report, and then I can use the report and all that data for, again, nice project web page, dashboard, something that, for instance, might be handed over to an assessor, and so on and so forth. Again, now that my computer seems to work, I might even be able to show you live. And what that does at the end of all of this, once you have your release run, you get what I just was talking about. You get your project website with, in this case, embedded trustable compliance report, highlighting our beloved README node, the score for that, and so on and so forth. Let's try out whether I can show you a click around live a bit. But that's essentially the brief, short version of what I've built. It is not very complex, but it is quite a lot of tools that I'm integrating here. So the repo looks quite busy, even though content-wise it's just that stupid README example. But anyways, so that was the principle. And now what I've also added is one little feature. It's a little feature, but it's my favorite feature, and I'll show you to wrap this up. Because that was the first time for me personally where it clicked when I understood the value of requirements tracing. Because in the past, people have been talking at me and talking at me about having the need for having requirements, and then people showed me requirements documents, 500 pages of things that nobody ever reads, much less understands, much less is able to even make coherent sense of. So what I've done here to kind of make this make sense for myself, and I do like the result. I use requirements tracing in this project as well. There's a little open source tool called OpenFastTrace, but you can use any tool, things, needs, whatever. OpenFastTrace is very simple, and we're using that for another project as well. So what it boils down to is you specify a requirement. This is stupid, right? But this requirement says I have to have a README. that requirement gets a requirement identifier and essentially a little statement that says, okay, this requirement needs an implementation to be complete. That's requirements tracing 101. You guys know how that works normally. I'm implementing the requirement. So this is the header, the top of my README file. This little snippet here essentially just is the open fast trace syntax, which says, okay, this file, this location is an implementation of this requirement identifier. And then, the rest of my README follows. And the open fast trace tool will go through your code base and will pull out all of these little references and create a coverage graph, right? What these tools tend to do. So in my release workflow, I'm doing the open fast trace analysis, and here I'm using a requirements identifier, like this one, requirements identifier. I'm using that identifier as a type of evidence for my TSF graph, for the project README thing. And by combining these tools, and again, not doing anything intelligent on my part, just putting these things together, the end result is in that TSF report for this node, for the evidence section of this node, I can now render out that little representation of my requirement. So like for this node, I'm using this requirement as evidence. I get the requirement text, I get the requirement specification location, I get the status of the requirement, and I get clickable links to wherever things are implemented, tested, and so on. And this, again, is almost for free, but this means now actually you have requirements accessible in the context of the actual bigger quality goal and, the kind of thing that you actually want to do. And again, this might be simple and stupid, but for me, that was the first real useful application of that concept, because now, it's where you expect it to be. Anyways, Sarah, what did you do? Okay. No worries. Let's see. The link is here. The link is also. Maybe status of closing thoughts. What I've built here, and you are very much invited to have a look. This is right now living in my own GitHub account. Essentially, this is not an Eclipse project or anything. However, I would like this to be a bit more visible / useful to people, which means we started a conversation with the TSF project, started conversation with the Eclipse folks and the Eclipse Dash project to kind of maybe later this year move these pieces over to where they make sense. So I have 2 GitHub actions. I have my example template hello world thing, and I do have a little renderer for my, for some of these evidence types. All of these would belong or make a lot of sense in these locations. The conversation about that has started. So right now, if you look at that link on the next page, don't be surprised. This is my repo. It's gonna move somewhere, I hope. If you want to read about that, TSF in general, there's one pointer here that you can use as a starting point. And anyways, again, links all over the place. Let me know, you'll get the slides. Now we just need to get it on screen. Yay. All right. You guys rock. Okay. This is the project website that I showed you earlier, that I'm generating with my release CI pipeline, and that I'm essentially uploading to GitHub Pages. This is an MKDocs, materials for MKDocs web page. You can see, this is the version, or like the generated page for release 016 of what I've been doing. Overview page, I've got my, all the project README, everything that I told you, a lot more structured and clearer. I've tried to write down here. Can have a look. little things that are for free because the data is there. I can just add a little badge giving the last scoring that I got for that release. Right? This is cheap. This is a one-line link web API call. That's all of that is getting very easy once you get your things all in that one place. And can look at I talked about requirements tracing. So for instance, the Open Fast Trace report for this release is available, can be published, can be looked at. You can follow the requirements, things that you're interested in. I've got the Trustable report. There's a dashboard. Again, don't get hung up by the score. It's horrible, but this is about the README, not about the score. And the little feature I was talking about, we are talking, this is the detailed report that you get, just generated by TSF, by the tooling. There's a bunch of nodes that I'm not doing anything with, right? That's the majority of my tree, but I do have something for my README. Can click on that. Now you get the detailed breakdown of why this thing is getting the score that it's getting. Down here, that's the evidences that I've been providing. So my download URL for the README, that's the first one. That's unexciting. I can now click here and I'll be taken to that file. And again, the little feature that I like is this one, where you essentially now get your breakdown of this requirement. You can look at where it's defined. You can look at the implementation and so on and so forth. Again, the repo is also online, but I don't want to jinx my luck now. Thank you for listening. Thank you for sticking this out until the end.